Hello, guys. Good morning once more. This is a bright morning that the Lord has given us, and we have to rejoice in it. So, there we are again with the 2023 KQ. If you like it, you can call it 2023 KCSE qualifiers or projections from New Yankees. So, we are still on with our course, and we have to up our game to finish the course as soon as possible. So, for my candidates, I hope we are ready to go. And there we are, question 23, that reads the figure below. DA is a diameter of the circle center O, radius 10 centimeters. Then TCS is a tangent to the circle at C. And more information, AB is equal to BC. Then angle DAC is 38 degrees. So the questions follow. Find the size of the angle. Find the size of the angle A Roman 1 ACS, that is ACS, and BCA. So then finally, the last part of the question, calculate the length of AC, and AB. So let's go to solution. So this is purely a good question for us, and we can't afford to lose the 10 good marks. Like we said, it is very easy to pass in maths. You just need to plan, have courage, and move through. Use what your teacher has taught you, and you will be able to tackle it. So let's see. So the concepts of angle properties of a circle, here they are, and we need to employ them. The first rule we all know, and now that we have been given the diameter here, let me draw my rough one. Given a diameter, center O, and any angle that is subtended by the diameter on the circumference, we all know is always 90 degrees. So here we are, and I can see one. And now that DOA is a diameter, and D subtends an angle at C with respect to A, and therefore this becomes 90 degrees. So this opens another way for us. Immediately we see 90 and 38. We know the angle sum of a triangle should add up to 180 degrees. So 90 plus 38 plus x should be 180 degrees, and therefore the sum of this and that will give us 128 plus x is 180. So collecting my like terms, I will have 180 minus 128. Then finally the remainder becomes 52. So our angle here is 52 degrees. I hope we are together. Then now that we have solved this triangle, we really have to think outside the box again. More properties of angles within a circle. So we have here, I'll use the idea of cyclic quadrilaterals. That is ADCB is a quadrilateral within a circle. We call it cyclic quadrilateral, and the concept here will be that the opposite angles here are usually supplementary nature. That is, they add up to 180 degrees. So my opposite angles here are 52 and B, the angle at B here. So that is 180 minus the 52 to get my angle at B, and that will automatically be 128 degrees. So I will be having my 128 there. Then we were given from the statement and on the diagram that line AB and BC are the same. So this one gives us an isosceles triangle, and we all know the base angles within an isosceles triangle should be equal. And what are they sharing? Out of 180, one side has gone with 128, and therefore what is left for the two is just 52 degrees. So we are sharing the 52 among the two sides. So each shall be 26 degrees. So therefore we come to the diagram, and this shall be 26 degrees. So looking at our diagram, it's like we have done all the angles, so except these two. So for me to be able to get this angle BCS or DCT, we have to employ another idea in Form 3. That is angles in alternate segments. Angles in alternate segments. That is, if I have my circle here, with a tangent at say point C, then I shall be able to say that this angle here, A, say A, is in alternate segments with the angle B here, and therefore these two angles are said to be equal. So coming back to our diagram, the same thing we are able to see here. Taking this triangle about the tangent, then angle BCS is in alternate segments with angle BAC, which is 26 degrees. And therefore, the same thing is seen here with angle DCT being in alternate segments with that of CAO or CAD, which is 38 degrees. So there we are. I'll repeat once more. I've said the 26 has come from this concept where angles in alternate segments are usually equal, and that is how we have been able to get 26, because it is within the alternate segments to as the 26 we have here. The same thing we have seen here with 38 and the 38 on the opposite segments. So at the end of the day, now we can answer our questions because it's like we have done a good part of them. Angle ACS, the whole of this angle. So we shall be able to add. So we say angle ACS shall be 26 plus 26, and that is 52 degrees, and that is 52 degrees. Then angle BCS, BCA, so angle BCA is 26 degrees. BCA, that angle there. So going to the last part of the, so we have our 4 marks already. I hope you are together up to that level. So going to part B, where we are told to calculate length. Calculate length of AC and AB or BC, now that they are equal. So this is very easy, and I believe all of us can tackle it. So here we go again. Let me extract my triangle. Here is the triangle, and it is 90 degrees at this corner. The length needed is here, CA, but the hypotenuse being the diameter, we were given the radius was 10, 10. So the whole diameter becomes 20 centimeters, and the angle there is 52, as we have 38 there. So we can use any method, either SOHCAHTOA, or I can use sine rule. So because I know we are all familiar with SOHCAHTOA, most of the students, let me use sine rule. So sine rule states that A over sine A should be equal to B over sine B, which is usually equal to 2R. That is 2 times the radius, or we call it now the diameter. So this is true. So I can extract any part of the ratios. And where am I? A for this matter. Now I'm just substituting without looking at really what the letters are. I'll now take my 20, and the angle here is 90. So 20 over sine 90 will be equal to B, taking 52 as my B, and X, so X is the length, over sine 52 degrees should be equal to 2 into R. R was 10. So this is true. Even if I try to block this, it is true that sine 90 is a 1. So 20 divided by 1 will still be 20. And therefore 20 is equal to 2 times 10. And therefore I will be true to use this. Yeah, because it's still the same. It's a common ratio. So we just come here and say therefore x over sine 52 degrees is equal to 20. That one is extracted from here, and therefore we can press our sine 52 from our calculators. We shall get x over 0.7, x over 0.7880, which is equivalent to 20. So getting x, we can cross multiply and say x times 1 is x, 20 by 0.7880 shall give us 15.76. 15.76. Like I said, you could still use SOHCAHTOA here. SOHCAHTOA. Those are ratios, because these are right angle triangles. So because we have hypotenuse, we can use sine or cos. So cos will really apply to now that we need x. So for example, saying ka adjacent or so opposite of hypotenuse, yeah, sine 52 can work better, or cos 38 can work better. So we'll be able to still get this, but I chose to use sine rule to also help those who are not well conversant with sine rule. assuming that most of the students are well conversant with soccer talk. So the last part of the question now reads, we need to get AB, and AB from our diagram. Here it is. Now that we have gotten here to be 15.76 centimeters, now we need this side AB. Still, I'll be able to use the sine rule. The sine rule, which we all know, and sine rule again, where A over sine A is equal to B over sine B, which we have said is equal to 2R. So 2R is 20. So the side that I need here, is very simple. Its opposite angle is, let me let it be another x here. Its opposite angle is 26. Its opposite angle is 26. So I'll take 128 with the already calculated side. So what do we get here? Therefore shall be 20 is equal to B, where B is 15.76 over sine 128 degrees. So cross multiplying, we shall be having 15.76 is equal to 20 sine 128. So we shall divide by, what are we working? Let me confirm, sorry. We want x. No. So we have to use, there's a problem here. We are saying this is the formula. So 20 is equal to B over, and our B is equal to x. So our 20 should be equal to x over sine 26. Sorry for that, just a slight mistake. So as we cross multiply this, we shall be having x as 20 sine 26, which we shall get 8.767 centimeters. 8.76 centimeters, and that is our length AB. So that is exactly how we go through this question, and we'll be able to, please check here where we have said we are still going to use sine rule, and the side of the triangle that we need is the one I've let x here, and its opposite angle is 26, please, not 128. So now that I decided to use the sine rule, and sine rule equated to 2r, the ratio is equal to 2r, and we all know 2r is 2 times the radius, which is 20, should be equal to the ratio, and the ratio here is our unknown side over the opposite arm. So we work it out, cross multiply, then x shall be 20 sine 26, which is 8.767 centimeters. Thank you guys. Let's study maths. Let's help one another, and we shall be making a difference. Learners, please, let's pay attention. Let's study. You can do 2 more. I'll be posting more questions for you. Please, let's do maths. The moment you will realize that maths is doable, then even the rest of the subject shall be very easy for you. Thank you very much, and may God bless you.